The overall goal of this procedure is to develop a methodology using a 3D depth inversion illusion to clarify the role of top-down visual processes on motor action. This is accomplished by first constructing an apparatus that presents a robust 3D reverse perspective stimulus to perform reaches under different perceptual states. The second step of the procedure is to set up a motion capture system to record a participant's interaction with the stimulus. The third step is to create a platform that allows participants to reach for where they last perceived a target located on the stimulus without any online visual corrections or haptic feedback. The final step is to analyze both the forward reach data as well as the non-instructed retraction of the arm to build a comprehensive model of visual motor behavior in this context. Ultimately, results can show changes in reach dynamics under different perceptual states through the kinematic assessment provided in this paradigm.
The main advantage of this technique over existing methods, like those that utilize the hollow face illusion, is that the retrospective stimulus allows for nearly 90 degrees maximal differences in surface orientation under vertical and illusory perceptual states.
This new method can help answer key questions in the field of perceptual science and begin building towards a more objective psychological science with new techniques that go above and beyond human verbal self-reports or key presses.
The very different predictions of the two hypotheses, in other words, whether the motor control system is influenced or not by the illusion, enable us to test these hypotheses. Demonstrating the procedure today will be Ravaliya.